Good morning, everyone. Today's class we are discussing about previous class we are discussing about uh, insulators requirements and different types of materials used for insulators and different types of insulators. So in this class we are discussing about advantages and disadvantages of suspension type insulators over a pin pin type insulators, right? And what are the causes of failure of insulators? Right, advantage of suspension type over pin type insulators. So above 50 kV suspension type insulators are cheaper than pin type. Right? Above 50 kV suspension type insulators is cheaper than pin type. Right? Each suspension type insulator is designed for about 11 kV to 16 kV depending upon the HT line. The number of insulators are connected in series as a string, whereas it is not possible in case of pin type insulators. So each suspension type insulator is designed for about 11 kV to 16 kV. So each disc contains approximately it is 11 kV to 16 kV depending upon the high tension line voltage. The number of insulators are connected in series as a string, whereas it is not possible in case of pin type of insulators. The string of suspension insulators are more flexible, due to which the stress produced by winds can withstand. So string of suspension type insulators are more flexible, due to which the stress produced by the winds can withstand. Pin insulators is more rigid. The pin type insulators are more rigid, hence the stress are transformed to cross arms. Okay. Though the pin insulators is more rigid, hence the stress is transferred to cross arms. The line conductor is fixed at below string of suspension insulators, which are hanged to cross arms of tower. So this line conductor is fixed at below the string suspension insulators, which are hanged to the cross arms of tower. The line is less liable to the effect of lighting disturbance. The line is run on top of the pin insulator, which is fixed above the cross arm, The line is liable to affect the lighting disturbance. The line is liable to affect the lighting disturbance, and the line capacity can be increased by adding insulators. Where it is not possible in case of pin type insulator. So pin type insulator, there is only one type of one disc containing it only one disc, but in case of suspension type there are more number of discs are connected in series. So because of this, the line capacity can be increased by adding insulators, whereas it is not possible in case of pin type insulators. Due to any reason, if any insulator is damaged in the string, then the damaged one can be replaced. Due to any reasons, if in suspension type or string type, any insulator should be damaged, one can be replaced. But in case of pin type insulator, the insulator is damaged, so the total entire disc can be replaced by another one. So in this suspension type insulator, we are replacing only one disc. So if pin insulator is damaged, it has to be replaced with new one. If the pin type insulator is damaged, it can be replaced with new one. But in suspension type, we are replacing only damaged one. But maintenance cost of suspension insulator is cheaper than the pin type insulator. The maintenance cost of suspension type insulators is cheaper than the pin type insulator. And what are the disadvantages of suspension type insulators over a pin type? So these are disadvantages of suspension type insulators over a pin type insulator. The spacing between the conductors must be more because of large swing due to winds and flexibility of string. The spacing between the conductors must be more because of large swing due to winds and flexibility of string. The spacing between the conductors must be more because of large swing due to winds and flexibility of string. The spacing is less due to rigidity of pin type insulators. The spacing is less due to rigidity of pin type insulators. And causes for failure of insulators. So because of cracks and manufacturing defect, the porosity of material, deposition of dust, and flashover, and mechanical stress. Right? So what are the causes for failure of insulators? Means breaking of cracks, manufacturing effect, porosity of material, and deposition of dust, flashover, mechanical stress. And short circuit. Cracks means porcelain, steel, cement are having different coefficients. Porcelain, steel and cement are having different temperature coefficient. So expansion is not uniform due to change in temperature. Expansion is not possible, not uniform in due to change in temperature. Stress on each material is not uniform. So the stress on the porcelain material is different, steel material is different, and cement material is different. So that material having the stress is not uniform. Hence cracks are developed. To reduce the development of cracks, elastic cushions are provided at junctions. To overcome these cracks, we are using elastic cushions or provided joints. Manufacturing defect. While manufacturing air bubbles are developed inside, if the material is not properly compressed and fired. While manufacturing air bubbles are developed inside, if the material is not properly compressed and fired, can be identified in routine test. So porosity of material. Porosity means if the insulator is not fired up the rated value at the time of manufacturing, this causes porosity in material. It absorbs the moisture from the atmosphere or from the cement. It reduces the resistivity of the material. Leakage current increases. Temperature of material increases. Hence insulator is punctured. So this can be reduced to some extent by glazing the insulator. So because of this atmosphere conditions, so the insulators will be failure. The deposition of dust. If the surface of the insulator is not properly glazed, water, dust and dirt retain on the surface. It reduces the path of leakage current. So water, dust and dirt retain on the surface. It reduces the path of leakage current. This can be easily avoided by cleaning the insulators periodically. So flashover flashover is nothing but in a flashover, an arc between the line conductor and earth, and the discharging jumps across the air gap in its path. So due to any reason, if the greater than the rated voltage appeared across the two metal parts of the insulator, that is pin conductor to cap to pin, it will cause overheating of insulators. Hence, the insulator gets damaged. So, due to this atmospheric condition, the insulator may heat it up to certain temperature. So, after that certain temperature, so the flashover will occur. So, when a breakdown due to flashover occurs, the insulators will continue to act in its proper capacity after the event unless fractured by the heat of the arc. So whether the insulator is dry or wet due to rain, the flashover voltage is expressed as dry flashover voltage or wet flashover voltage. Dry flashover voltage is more than the wet flashover voltage. And mechanical stress, the tensile strength of a porcelain insulator is low. So the stress produced due to heavy wind pressure, the insulator gets damaged. The short circuit. Short circuit means whenever a large bud reaches near to the insulators, the causes short circuit between the conductor and metal part of the insulator and damage the insulators. So due to these buds, it will occur at short circuit. So in this class we are discussed about different types of advantages and disadvantages of suspension type over pin type insulators and causes for failure of the insulators and some definitions, that is puncture, flashover. Puncture means in a puncture the discharge occurs from conductor to pin through the body of the insulator. After a puncture, the insulator becomes completely ruined. Right? So here I am explaining once again. I am explaining the class, that is what are the advantages and disadvantages of suspension type insulators over a pin type insulators. So what are the causes of failure of insulators? Advantage of suspension type over pin type insulators. Above 50 kV, the suspension type insulators are cheaper than pin type. So comparing the insulator suspension type and pin type insulator, as the voltage increases, the suspension type insulators are cheaper than the pin type insulator, but less voltages pin type insulators are suitable for transmission. So above 50 kV, the suspension type insulators are cheaper than the pin type, and each suspension type insulator is designed for about 11 kV to 16 kV. So in this case, here each disc of the suspension type insulators is approximately equal to 11 to 16 kV. Normally 11 kV only, but 11 to 16 kV depending upon the high tension line voltage. The number of insulators are connected in a series as a string, whereas it is not possible in case of pin type insulators. As the voltage increases, we are adding one more insulator to the one more disc to the suspension type insulator. But in case of pin type insulators, we are not adding the discs because it containing only one disc. String of suspension type insulators are more flexible, due to which the stress produced by winds can be withstood. So due to this, the suspension type insulators are more flexible, due to which the stress produced by winds can be withstood. So pin insulators is more rigid, hence the stress are transformed to cross arms. Hence the pin type insulators are more rigid, hence the stress are transferred to cross arms. The line conductor is fixed below the string of the suspension insulators, which are hanged to the cross arms of tower. The line is less liable to the effect of lighting disturbance. The line is less liable to the effect of lighting disturbance, which are hanged to the cross arms of tower. The line is less liable to the effect of lighting disturbance. The line is run on the top of the pin insulator, which is fixed above the cross arm. The line is liable to affect the lighting of disturbance. The line capacity can be increased by adding insulators, whereas it is not possible in case of pin type insulators. So in case of string insulators, the line capacity can be increased by adding the more number of discs in suspension type insulators. But in case of pin type insulators, it is not possible to adding the number of discs in pin type insulator. Due to any reason, if any insulator is damaged in the string, then the damaged one can be replaced. Due to any reason, if the insulator is damaged in the string, then the damaged one can be replaced. If the pin insulator is damaged, it has to be replaced with new one. Right? If pin insulator is damaged, it has to be replaced with new one. The maintenance cost of suspension insulators is cheaper than pin type insulators. The maintenance cost of suspension type insulators is cheaper than the pin type insulators. And the disadvantage of suspension type insulators over a pin type insulators. The spacing between the conductors must be more because of the large swing due to winds and flexibility of string. The spacing between the conductors must be more because of large swing due to winds and flexibility of string. The spacing is less due to rigidity of pin insulator. And causes of failure of insulators. Because of the cracks and manufacturing defects and porosity of material, deposition of dust, flashover, mechanic stress, and short circuits. So these are the causes of failure of insulators. Because of cracks, manufacturing defect, porosity of material, deposition of dust, and flashover, mechanical stress, and short circuit. Cracks. So cracks, the porcelain, steel and cement are having different temperature coefficient. Porcelain, steel and temperature having porcelain, steel and cement are having different temperature coefficients. So expansion is not uniform due to change in temperature, and stress on each material is not uniform, and cracks are developed. Because of this stress, cracks will be developed. To reduce the development of cracks, elastic cushions are provided at junctions. So elastic cushions are using here cracks. And manufacturing defects. While manufacturing air bubbles are developed inside, if the material is not properly compressed and fired. While manufacturing air bubbles are developed inside, the material is not properly compressed and fired. It can be identified in routine test. And porosity of metal. If insulators are not fired up to the rated value at the time of manufacturing, this causes porosity in material. It absorbs moisture from the atmosphere or from the cement. It reduces the resistivity of the material. Leakage current increases. So temperature of the material increases. Hence, insulator is punctured. Puncture means, in a puncture, the discharge occurs from a conductor to pin through the body of the insulator. So discharge occurs from conductor to pin to the body of the insulator. After a puncture, the insulator becomes completely ruined, and this can be reduced to some extent by glazing the insulators. Deposition of dust. If the surface of the insulator is not properly glazed, water, dust and dirt retain on the surface. It reduces the path of leakage current. This can be easily avoided by cleaning the insulators periodically. And flashover. Due to any reason, if greater the rated voltage appeared across two metal parts of the insulator and pin to conductor or cap to pin, it will cause overheating of insulator and the insulator gets damaged. But in flashover, an arc occurs between the line conductor and earth, that is supporting pin of the insulator, and the discharge jumps across the air gaps in its path. When a breakdown due to flashover occurs, the insulator will continue to act in its proper capacity after the event unless fractured by the heat of the arc. Whether the insulator is dry or wet due to rain, the over voltage is expressed as dry flashover or wet flashover voltage. So the dry flashover voltage is more than the wet flashover voltage. The mechanical stress. The tensile strength of porcelain insulator is low. The stress produced due to heavy wind pressure insulators gets damaged. The tensile strength of porcelain insulator is low. The stress produced due to heavy wind pressure insulators gets damaged. Short circuit. Due to this, whenever a large bird reaches near to insulators, causes short circuit between the conductors and metal part of the insulator and damage the insulator. Due to these large birds, the insulators gets damages. So in this class we have discussed about what the different advantages and disadvantages of suspension type insulators over pin type insulators and causes for failure of insulators. What are the causes? Because of cracks, manufacturing defect, porosity of material, deposition of dust and flashover, mechanical stress and short circuit. So these are the advantages and disadvantages. So we are discussing it in the class. In this class we are discussing about advantages and disadvantages of pin type insulators. So in this class we have discussed about the voltage distribution across string of suspension type insulators and flashover voltage definition, how to calculate potential across each insulator of string, the voltage distribution across string of suspension type insulators, flashover voltage definition, how to calculate potential across each insulator string, the string efficiency, flashover voltage and function. This is a string of suspension type insulators. Top disc of the insulator string is connected to the cross arm of the tower or pole as shown in figure. The top disc of the insulator string is connected across the cross arms. As shown in figure. The line conductor is connected to bottom of the disc of the insulator string. Each disc of the string behave like a capacitor having a dielectric medium between the two metallic parts. Each disc of the string behave like a capacitor having a dielectric medium between the two metallic parts. The voltage across the string of suspension insulator does not distribute itself uniformly across the individual disc due to the nearness of the earth. That means supporting towers. The metal work cap is connected link of each disc a capacitance relative to its metal work of the next disc. So each disc is having one capacitor across horizontal and vertical. Also the metal works as a relative capacitance to earth is known as ground capacitance. The, the metal work of each disc, capacitance relative to its metal work of the next disc, is known as mutual capacitance. And also a metal work has capacitance related to earth is known as ground capacitance. Hence the arrangement may be represented in figure. That is here shown in figure, that the each disc of the contains one capacitance, that is E1, E2, E3, E4. So here 4 discs are connected, that is E1, E2, E3, E4. Here it is phase, the potential distribution across the insulator string. It is potential distributor across the string. Here this is the pole of the here it is the conductor, here it is the tower, here it is the tower, and here it is cross arms. Here the cross arm is in green color, and the tower is red color, and the conductor in circle. So that is the relative, the pole to pole is conductor. The difference between the conductors is known as mutual capacitance. That is the metal work of each disc, a capacitance related to metal work, it is known as mutual capacitance. And the metal work, the metal work has a capacitance related to earth, that is known as capacitance, ground capacitance. In the string of suspension, the capacitance between the cap and steel pin is called mutual capacitance. Yes, the capacitance between the cap and steel pin is called mutual capacitance. Here is acts as insulating medium between the earth tower and pole, and metal part of insulator forms a capacitance and is called as shunt capacitor. Here the air acts as insulating medium between earth tower or pole and metal part of insulator form a capacitance and is called as shunt capacitor, shown in figure. The shunt capacitance value is very small when compared to mutual capacitance. Here the combination of shunt capacitance value will be very small. Here in this case we are adding only two capacitance, that is mutual capacitance and shunt capacitor. Mutual capacitance, the capacitance between the cap and steel pin is called mutual capacitance, and it is air acts as insulating medium between earth tower or pole. The metal part of insulator forms a capacitance and is called as shunt capacitor. Here the capacitance C1 C is the mutual capacitance, and C1 is the shunt capacitance. If the shunt leakage current can be neglected. If the shunt leakage current can be neglected, if the same capacity insulators are used as string, if the same capacity of insulators used as string, the current through the each insulator in the string would be same, voltage across each insulator would be equal. But in practical, the shunt leakage current has to be considered as a leakage current through each disc of the string is not equal to the potential distribution across each disc is not equal. Here the see and figure, here it is the E1 means mutual capacitance, here it is the shunt capacitance. Here the current is entering into the capacitance, that is here it is I1 capacitance, here it is I1 small I1 capital I1, I2 small I2 capital I2, right, and capital I3 small I3, and I4 small I4. Yeah, like the mutual capacitance of various units are in series between the line and ground. while the capacitance to ground act in the manner of series of shunts to ground, right? Here the greater capacitance current flows through the line disk 4 than 3, and hence voltage 4 is greater than 3, so on, and at least share of the total voltage being taken by the crosser units. So C is the ground capacitance and MC is the mutual capacitance. That is M, where the mutual capacitance is equal to mutual capacitance by capacitance to ground. Here see, let's see the derivation of potential across the string is C is the mutual capacitance and C1 is the shunt capacitance. C is the mutual capacitance and C1 is the shunt capacitance, and E1, E2, E3, E4 are the potential across each unit respectively. Across the string is E phase, right? And the voltages, that is E1, E2, E3, E4 are the branch voltages of each capacitance. That is voltage across the each capacitance. That is E1, E2, E3, E4. The ratio between shunt capacitance and mutual capacitance is K. Mutual capacitance into shunt capacitance is K. The Ky is equal to C1 by C, that is mutual capacitance, shunt capacitance by mutual capacitance. It is mutual capacitance is equal to C1 by C. See here. Here the mutual capacitance is this MC. Here the mutual capacitance is MC. Here the earth capacitance is shunt capacitance. It is here the voltage across the capacitance is E1, E2, E3, E4. The total voltage between this phase voltage, that is E. So here is the conductor. Here the shunt capacitance is C. Right? Here it is the mutual capacitance. Here the current flowing through shunt capacitance of the first disc is I1 and IA. Here it is I2 and IB. Here it is IC, I3. Here it is I4, ID. And the voltage across the capacitance is, here it is E, E1, it is E1 plus E2, it is E1 plus E2 plus E3, and shunt capacitance for last E1 plus E2 plus E3 plus E4. Right? So here the derivation, applying Kirchhoff law to the first loop, that is I2 is equal to I1 plus IA. I2 is equal to I1 plus IA. Here see IA is nothing but I1 is nothing but I1 means that is mutual capacitance. It is here omega is the mutual angular velocity, WMC into E1 across the voltage, WMC into E1, and the capacitance is WC into E1. Here the voltage across the capacitance is, it is W into MC into E1 for I1 current, but IA current W into C into E1. That is, here WC E1 is the common, that is 1 plus M. So I2 is equal to WC into E1 into 1 plus M, right? And the voltage across the E2 voltage is, E2 is equal to I2 into XC, I2 into XC, that is equal to I2 by XC is nothing but WMC. XC is nothing but 1 by 2 pi FC, that is equal to 1 by M mutual capacitance. That is I2 is equal to nothing but WC E1 into 1 plus M divided by WMC. So here WWC is cancel, WWC is cancel. That is equal to E1 into 1 plus M by M, that is equal to E1 into 1 plus 1 by M, that is equal to E2. E2 is nothing but E2 is equal to E1 into 1 plus 1 by M, and similarly I2 is equal to WC into E1 into 1 plus M. Right, and similarly the voltage producing, that is IB is equal to E1 plus E2, E1 plus E2. Here the IB current is equal to E1 plus E2, right? We know the value of IA and I1, we know the value of I2 also, but now we have to find the value of I3, then IB. So I3 is equal to nothing but I3 is equal to I2 plus IB. So first we have to find the value of IB, right? So IB is nothing but IB is equal to E1 plus E2. IB is equal to E1 plus E2. So E1 is equal to nothing but E1. E2 is nothing but E1 into 1 plus 1 by M, that is equal to E1 is common, that is 1 plus 1 plus 1 by M. So that is equal to E1 into 2 by 2 plus 1 by M. So E1 is nothing but IB is nothing but E1 into 2 by 1 plus M, that is equal to IB is equal to WC into E1 plus E2. IB is equal to WC into E1 plus E2. So WC into, what is E1 plus E2 is nothing but E1 into 2 plus 1 by M, that is equal to WC into E1 into 2 plus 1 by M. So IB, we get the value of IB. Similar I3 is equal nothing but I2 plus IB, I2 plus IB. So we know the value of I2, that is I2 is nothing but WC into E1 into 1 plus M plus WC IB is equal to E1 into 2 plus 1 by M. So WC E1 into 1 plus M plus 2 plus 1 by M, that is equal to WC E1 into 2 plus 1 3 plus M plus 1 by M. So I3, so we get the value of I3, that is I3 is equal to WC into E1 into 3 plus M by M plus 1 by M. And so I3 is equal to WC into E1 into 3 plus 1 by M. But I2 is equal to WMC into I3. I2 is equal to W into MC into E3. I2 is equal to WMC into E3. So E3 is equal to I2 I but we have a formula that is I3 is equal to WMC into E3. That is E3 is equal to I3 by WMC. What is I3? I3 WC into E1 into 3 plus M plus 1 by M divided by WMC. So W cancel, CC cancel. So that is E1 into 3 plus M plus 1 by M. So E3 is equal to E1 by 3 plus 1 by M by M. So that is equal to E1 into 3 by M plus 1 plus 1 by M square. So multiply with M, multiply divided with M. So that is E3 is equal to E1 plus 3 by M plus 1 by M square. And the voltage producing is E3 is equal to this IC is equal to E1 plus E2 plus E3. So here it is the IC is equal to E1 plus E2 plus E3. So IC is equal to E1 plus E2 plus E3. So here IC is equal to E1 plus E2 plus E3. So that is equal to IC is equal to E1 plus E2 plus E3. That is E1 is nothing but E1 plus E2 is nothing but E1 into 1 plus 1 by M plus E3 is nothing but that is E1 into 1 plus 3 by M plus 1 by M square. So E1 is common. It is 1 plus 1 by M plus 1 plus 3 by M 1 by E1 into 1 plus 1 2, 2 plus 1 3, 1 by M plus 3 by M 4 by M 1 by M square. So IC is equal to that is next, and the form for IC is WC into E1 plus E2 plus E3. So that is WC into E1 plus E2 plus E3. E1 into 3 plus 4 by M plus 1 by M square. So WC into E1 into 3 plus 4 by M plus 1 by M square. Similarly, there is I4 is equal to IC plus I3. So I4 is equal to IC plus I3. IC is nothing but WC E1 3 by 4 by M plus 1 by M square plus I3 is nothing but WC E1 into 3 by 1 by M plus 1 by M square. WC E1 is common. 3 plus 3 6 plus 4 by M plus 5 by M and 1 by M square plus 2 by M square. This I4. So E4 is nothing but I4 by WMC. I4 is nothing but I4 by WMC. That is equal to WC into E1 6 plus 5 by M plus 2 by M square by WMC. So WWC cancel. E4 is equal to E1 into 1 plus 6 by M plus 5 by M square at 1 by M cube. So we have that is E is equal to E1 plus E2 plus E3 plus up to so on. If the number of insulators increases, so the number of insulators is increases, so this is the derivation. Similarly, each capacitance has each disc having same formulas. So no, here see here E4 is greater than E3, E3 is greater than E2, E2 is greater than E1. So E2 is equal to E1 into 1 plus K, E3 is equal to E1 into 1 plus 3 plus 3K plus K square, and E4 is equal to E1 into 1 plus 6K plus 5K square plus K cube. So potential across disk which is near to the conductor is maximum. Near to the conductor is maximum. Near to conductor is fourth conductor, that should be maximum. So potential across each disk which near to the cross arms tower to pole is minimum. So near to the cross arm should be minimum and the conductor should be maximum. So in this class we are discussing about the derivation of potential difference across a string of suspension insulators. Potential difference of across is disk insulator, that is E4 is equal to E1 into 1 plus 6 by m plus 5 by m square plus 1 by m cube. Okay, K is here, K is nothing but K is equal to nothing but 1 by m mutual capacitance. Okay, thank you.